Hello, my name is Mike Smell, and welcome to another episode of Simulation in Action. In this episode, we'll watch as my colleague Parker Wright discusses how we can use Simulation CFD for AEC, MEP, and engineering service provider applications.
Hi, my name is Parker Wright. I'm with the Autodesk Simulation CFD team, and I focus on AEC, MEP, and our engineering service provider clients. So I'm going to talk about that in a little bit of detail today. So let's start with some background. What is CFD? CFD is the modeling of air and fluid flow as it interacts with surrounding solids in its simplest form. It stands for computational fluid dynamics. In this case, fluid could be liquid, gas, air, anything that we can physically describe. And dynamics, of course, means movement. Typically, CFD tools also include modeling the effects of temperature or thermal influences. So today, CFD for your space stands for airflow and thermal or temperature profiles. So let's take a look at CFD in action. This is the financial district in downtown Manhattan, and we're taking a fly-through using Simulation CFD and Showcase. So we've mapped the results in, and we're actually flying through the city and understanding how wind currents behave due to the interaction between the buildings. It's very visual, very interesting. So now, that's at a very high level, so we can model airflow around buildings, within buildings, water flow within wastewater tanks. So let's dig a little bit deeper and look at the business value for adding Simulation CFD to Building Design Suite. So it allows our clients to examine innovative approaches quickly at a low cost. They can look at natural ventilation, chilled beams, displacement ventilation, underfloor air distribution, stack effect, and radiant heating and cooling. Firms typically purchase CFD in order to mitigate design risk. So with environmental standards becoming increasingly stringent, LEED, Net Zero, and BREEAM, to name a few, almost mandate these types of studies. But the most common reason that CFD is implemented in-house is to win more bids by demonstrating design merit and core competency during the bidding process. Also, it allows you to maximize the value of your Revit, BIM, or 3D modeling investment. Okay, so now let's look at Simulation CFD plus Building Design Suite in action. This is a hotel in Portland. And as we zoom in, we can see that we have the full Revit model. This is in Revit MEP. Now we're looking at a conference room, multiple tables and chairs and people, and we want to understand the flow and thermal effects due to the ventilation system inside. So firms will run these types of simulations to try to cut down on energy costs and improve thermal comfort and safety. Here we see that the Revit data has been transferred over as well, so we can automatically map materials into the CFD model. And now we're looking at cut planes, 2D slices, and 3D ISO surfaces within the space, showing temperature and velocity profiles. Lastly, we'll take a closer look at thermal comfort and understand if individuals within the space are satisfied or dissatisfied with their current state. So how does Simulation CFD fit into the process? It all starts with a BIM or a CAD model, so you can start in Autodesk Revit, Inventor, AutoCAD, or even other CAD programs. The model is pulled into or natively integrated into Simulation CFD for ventilation system design, radiant heating and cooling, thermal stratification, design day studies, thermal comfort, solar loads, contaminant migration, stack reentrainment, smoke visibility, stack effect, natural ventilation, wind wake patterns, and wind loading, to name a few. You then communicate results with architects and the design team and the clients and the owners. So it really allows you to more effectively collaborate within your teams and communicate with external clients or stakeholders. Now, how about Factory Design Suite? So there's significant business value between CFD and Factory Design Suite as well. Our clients use it to meet EPA and OSHA requirements with respect to controlled and fugitive emissions and temperatures. So on the upper right, we can see an internal ventilation shot, and in the lower left, that's more of a controlled emissions stack reentrainment type study to ensure that pollution is not entrained in a building next door. Now let's look at Simulation CFD plus FDS in action, Factory Design Suite. So here we're looking at 4 different factory conceptual designs, understanding the thermal profiles on the equipment and what type of influence changing the ventilation design has both on the temperature profiles around the equipment, but also on the ventilation costs. We've now pulled the results into Showcase, and we're using these again to communicate with those external stakeholders and show them what this looks like, the airflow patterns, within the context of a real-life model. Very powerful. Okay, now let's look at some specific case studies. So in this case, our client used Simulation CFD to run an energy audit on an existing lab building. On the left, we see the as-built configuration. It's very drafty, a lot of very high velocity or high airspeed areas. So all the areas that are red are drafty, high velocity zones, and all the areas that are dark blue are very slow, stagnant areas. Now the high speed zones make people uncomfortable. The low speed zones are even more dangerous though, because these are areas where chemicals or contaminants could accumulate if we have a spill or something's broken in the lab during the course of normal working hours. So we want to eliminate both the drafty zones, the high velocity zones, because those are wasted energy, and we want to eliminate the low velocity dark blue zones as well, because those are dangerous areas where chemicals could accumulate. On the right, we see the optimized retrofit design, and we can see that within each of the aisles, we have nice, consistent, laminar, unidirectional airflow, which is going to sweep the counters free of any debris or contaminants and ensure worker safety. That also makes for a very predictable thermal profile within the lab and makes for good thermal comfort. So we cut down on occupant complaints. What's really amazing about this is we're able to do all this, or our client was able to do all this, while cutting down on energy costs. So you can save anywhere upwards of $100,000 to even $500,000 in a campus per year just by reducing the number of air changes per hour within a lab space like this. The next one shows interior ventilation and thermal comfort within an atrium. So whether you're looking at offices, atria, performance halls, museums, or even dining spaces, atria are more and more common. They're very visually and aesthetically appealing, and they're incorporated into many more designs today. So they look great, the architects love them, but as an MEP engineer, this poses a whole new set of challenges. It's very difficult to design these without over-conditioning the space, because it's hard to control the airflow because you have multiple stories of open environment where the air can do whatever it wants to. So with CFD, you can model and predict exactly how the airflow is going to behave so that we can condition only the occupied zone. We only want to condition the area where people will be inhabiting. We don't want to condition empty areas, so this is extremely useful in large performance halls or in large gathering spaces. Again, very useful in office buildings as well. And what we see here is the top design was the as-built. The bottom design actually incorporates radiant panels for heating and cooling to reduce the total ventilation loads. As we know, radiant energy is much cheaper. We're pumping water up to the radiant panels and then using radiative heat transfer to warm or cool individuals, so it's much less costly than forced air ventilation is. Okay, so by using this radiant approach, office buildings can realize up to 50% energy savings by using a strategy like this. Again, we pull the results in the showcase for our client presentation or for our bid submission and deliver the most impactful visuals we can to the client, owner, or prospective client. Next up, natural ventilation. So natural ventilation is gaining popularity in many areas on the West Coast, in Europe, and even in Asia for facades. So in this case, we see a school, but public spaces, data centers are using natural ventilation concepts as well, and it gives us the opportunity to improve the sustainability. Of course, this is essentially free air, and also improve the indoor air quality. If we consistently and strategically introduce fresh air into the spaces, using our external natural resources, then our air quality is going to go up, and typically comfort and satisfaction levels within humans go up as well. So using natural ventilation, we can help reduce energy consumption by anywhere from 10 to 30% depending on the space. So now let's switch gears and look at data centers. Here we're showing a video. This is a data center spinning around. Typical hot aisle, cold aisle, subfloor plenum arrangement. And we can actually track the airflow through the data center to understand how it's delivered to each individual rack and more strategically design it so that airflow is delivered to more of the warmer racks and less of the cooler racks. So here we see trace particles or streamlines actually brought from Simulation CFD into Showcase to show the impacts of moving around crack units or air conditioners, changing subfloor tiles, removing ceiling tiles, and what the effects are on both the performance and the sustainability of your data center. So within data centers, we want to maximize the usage of cooling air, maximize the usage of our crack units. So whether you're designing something for new construction a retrofit, if you're looking at different containment strategies, fresh air cooling, as I mentioned before, or even modular data centers, CFD can be very beneficial. New data centers can cost anywhere from $300 to $400 per square foot. So with some simple math, you can see that they can exceed $1 million very quickly. So by retrofitting existing data centers with more modern equipment, your clients can save $100,000 or more year over year just in ventilation costs. So how does that happen? Energy conservation measures, ECMs. So ECMs are using some very simple design changes within the data center to change the performance and deliver a more sustainable, energy efficient design. So typically, simple ECMs could mean moving tiles around, could mean adding baffle curtains, adding blanking panels, and then we can rise up to changing out crack units for more efficient plug fan, belt-driven, variable drive crack units, or even leveraging free air cooling, close couple cooling, doing some pretty creative things, maybe with some containment type strategies as well. Those are more expensive to implement, but also yield a bigger payback. So we have a nice broad range here, but even at $1 or $2, $3 per square foot per year, this can add up pretty quickly as well. And you can see that we can start to see some serious gains with a less modest investment. So typically see a 2-year payback, and again, about $100,000 per year minimum on energy savings. So the screen capture we're showing here, the results shot, is a thermocouple within Simulation CFD that's been placed in a strategic location so we can monitor the effects of different design changes within the data center. We get that real-time feedback from the tool. Smoke migration is also a very important topic. Again, with atrium design, smoke abatement and smoke handling and makeup air systems are becoming more and more difficult and more expensive to design. NFPA, National Fire Protection Agency regulations stipulate a certain amount of airflow per unit volume of air within a space. So with Atria, that number goes up very quickly and results sometimes in designs that are actually impossible to build. We also see a lot of smoke migration simulations in arenas, within parking structures. This is huge, and within non-standard design concepts. So if you have a ceiling where it has features that smoke might tend to accumulate within, then that's a great fit for CFD as well. So typically with smoke abatement and smoke migration, you can expect a reduction in equipment and generator sizes because frequently you can reduce the size of the makeup air system. You have to prove it out with simulation, but once done, it helps you reduce your equipment sizes, save anywhere from $20,000 to $50,000 to $70,000, again, from proving that that smaller makeup air system works effectively. And the last one here is water and wastewater management. We're seeing a rise in requests for CFD in this as well. Whether you're working on potable water tanks, wastewater tanks, or even reservoirs. So on the top we see a tank filling, and on the bottom we see a large reservoir filling as well. So strategically placing inlets and outlets, understanding residence time, trying to prevent microbial growth, looking at fill and draw cycling with respect to time, all very important to this industry. So I'll close today with a video from Autodesk about designing better buildings. We have a total portfolio of solutions that we offer to help you design better buildings. Simulation CFD is one very important part of that allows you to look at efficiency, sustainability, airflow, and again, accurately predict and show your clients exactly why the design that you're putting together for them is the best. So if you have any questions, I encourage you to reach out to us today. Thank you.